In today's lesson, we are going to be looking at simplifying, multiplying, and dividing rational expressions. So this is going to be a new concept for this unit. It's going to be something that you haven't really looked at before. The previous two lessons were dealing with powers and exponents and fractions, which you have dealt with before. This is going to be something different because we haven't really looked at rational expressions too much in previous units. So we want to start off with, well, what is a rational expression? A rational expression is a quotient of two polynomials. So p of x divided by q of x, where q of x does not equal 0. And this is something that we have kind of touched on briefly when we looked at domain and range all the way back in the beginning. But again, with a rational expression, similar to rational exponents, rational just means a fraction. So we have expressions dealing with fractions, and we have a function on the top and a function on the bottom. So what does a graph of a rational expression look like? Well, this is what one of the possible rational expressions looks like. And there is something different in this graph that you may not have seen in other graphs that you've looked at. And that is the fact that we have a hole. There is an open circle in our line. So we have a hole at x equals 2. And if we look at the function, f at x is equal to x squared minus 2x divided by x minus 2, why might we have a hole at x minus 2? Think back to when we looked at domain and range. We did look at some rational expressions. What do we notice? Well, we've talked about rational expressions before, and if you kind of read while I've been talking, you would have seen, maybe read the square. But if I look at this denominator, x minus 2, we talked about rational expressions. We cannot have x minus 2 equal to 0. Right? X minus 2 cannot equal 0, because if it did, that means we would have a fraction with a denominator of 0, which is not possible. So when we solve, we get x can't equal 2. It can equal everything else in this line, except it can't equal 2. So that is why we have an open circle. So the open circle represents a hole in the graph, and this basically refers to a restriction. So basically it means that this graph does not exist at x equals 2. And with rational expressions, looking for restrictions is something we're going to have to be mindful of. We need to be aware of where does this function or where does this expression not exist. So stating restrictions is basically just checking to see where the denominator is equal to 0. And where we find that it's equal to 0, those are the restrictions. Because we cannot have the graph existing at those spots. And when we're dealing with rational expressions, again, we need to check for restrictions. And the restrictions must be stated when the expression is simplified. So we're going to be going through and simplifying these rational expressions to make them a little bit easier to write, but we need to keep in mind, we need to be aware of what the restrictions are, because in the simplified form, we might not see the same restrictions as we would in its original form. So we're going through simplifying, canceling things out, things like that. The restrictions start at the original form, and then they progress as we go through. So we need to be aware of the restrictions, especially when we simplify, because we might not see the same thing as we originally did, even though the original one is still the same equation. So again, we just want to make sure that the bottom of the fraction can't equal 0. So the bottom of the fraction can't equal 0. So that's what we're going to be looking for as we go through and simplify. So let's just take a look at a couple examples and just state the restrictions for the following rational expressions. So for the first one, x plus 2 divided by x minus 2. So we're looking at the bottom, x minus 2, this denominator cannot equal 0. All right, so we're going to solve for x to figure out what x can't be. Move the negative 2 over, becomes positive 2. So this is my restriction. My restriction for this rational expression is that x cannot equal 2. If I look at b, x plus 2 divided by x minus 3 times x plus 4, I have two factors in the bottom of my, or in the denominator of my fraction. So the bottom or the denominator cannot equal 0. Similar to when I'm solving by factoring, if x minus 3 times x plus 4 cannot equal 0, that means either of these factors cannot equal 0. So just off to the side, this is what I'm stating. I'm going to go through and check now. So I'm going to say x minus 3 cannot equal 0, and x plus 4 cannot equal 0. And I'm going to solve. I'm going to get x equals, move the negative 3 over, it becomes positive 3. Move the positive 4 over, it becomes negative 4. So x cannot equal negative 3, x cannot equal negative 4. So I'm going to state at the end all my restrictions together. Oops. I don't know if it matters which way the cross between the equal signs goes, but x cannot equal 3 and negative 4. So that is my restriction, or my restrictions. For c, 5 divided by x times x plus 3. So again, I have two parts for this denominator. So x times x plus 3 cannot equal 0. So I'm going to set each factor not equal to 0 and solve for the variable, or solve for x. So x cannot equal 0, that's already done. X plus 3 can't equal 0, so that means x can't equal negative 3. So then altogether, all my restrictions, x cannot equal, again, I think I did those backwards. Let me just go through, try to keep it consistent. So x cannot equal 0 and negative 3. And those are my restrictions for this function. So that is essentially what we're doing when we're looking for restrictions. These ones were a little bit easier because the denominators were already kind of factored or in factor form. In some cases, they may not. So we might have to go through and factor it. So some rules to consider. Right? One rule, right, we can only cancel out when multiplying fractions. So again, we kind of talked about this before, right? So we can only cancel out factors when we're multiplying fractions. So again, like I said, we see some examples here. We cannot cancel out when adding or subtracting fractions. Again, we've talked about this before. I could break it apart and then maybe factor or cancel out each individual term. However, we would then have to combine them again anyways, which wouldn't really make sense, because by combining or adding the fractions, I would then have to find common denominators and so on, and I would probably be right back to where I was. So again, if we're adding, we cannot cancel out, but if we're multiplying, we can. Just things to keep in mind as we kind of go through and start to simplify some of these rational expressions. So let's go through and simplify. Right? We want to simplify and determine any restrictions on the variable. So if I look at the first one, 3x squared divided by yx. So I'm going to go through and I'm going to state some restrictions. I'm always going to start off with doing it based off of whatever I have. Right? So I have that y can't equal 0 and x can't equal 0. Right now, that can't, those two things have to be true. They both can't equal 0, because then the denominator will equal 0. Now I'm going to go through and start to simplify. Is there anything I can cancel out? Well, I can use my power laws to cancel out some of the x's. So I'll be left with 3 dividing power says I subtract. So x to the power of 2 divided by x becomes just x to the power of 1, or x. And it's going to be divided by y. So that means, let me move this up top. That means that my simplified expression is now 3x divided by y. And the restrictions are that y cannot equal 0 and x cannot equal 0. I know I'm writing these down multiple times, but I'll put these ones in, say, put them in pink. So what I'm going to do, or what we want to start doing, is we want to start looking for the restrictions as we progress through, right? Because if I look at this simplified form, I only see the y. However, my actual expression has the x in the denominator as well. So we wanted, as we simplify and go through, and as we look at more and more complex examples, we want to make sure that we are keeping track of our restrictions as we go through the simplification process. So in pink will be the ones that we're looking at as we go through, and then at the end we'll restate all of the restrictions. For B, I have x minus 3 divided by x squared plus 3x minus 18. So we're looking at the bottom, or the denominator. This is a simple trinomial. So right now, I can't look at this and say what my restrictions are, because I would have to solve basically for when x equals 0. With a trinomial, it can be a little bit difficult. We'd have to use the quadratic formula to find our x-intercepts. Or that would only, we could find our x-intercepts, so to speak. But it's also easier to factor. So I can factor, right? So again, product of negative 18 and a sum of 3. So what two numbers multiply to negative 18 but add to 3? We have positive 6 and negative 3. So that means that my expression now becomes x minus 3 divided by x plus 6 times x minus 3. At this point, now I can look at my denominator and say, oh, I have factors now. I can set these equal to 0 or not equal to 0 to find my restrictions. Right? So I know that x cannot equal negative 6 and it cannot equal positive 3. Good. So those are my restrictions right now. Right? We've looked at the previous example of how we're going to do it. So if you can kind of just do the shortcut of knowing that you're basically figuring out when can each factor equal 0? Well, negative 6 and 3. Okay, those are my restrictions. That's what x can't equal. I'm now going to look to simplify. Is there anything I can simplify? Well, on the bottom I have an x minus 3, and on the top I have an x minus 3 as well. I can cancel out the entire thing. And the reason I can do that is because technically the x minus 3 itself is being multiplied by 1. So in this case, I am allowed to cancel out. I'm not canceling out an individual term. I'm canceling out the entire portion. So then I'm left with, not x minus 3, I'm left with 1 as a placeholder on top divided by x plus 6. I just want to make sure I have my colors right, so I kept it in blue. And then my restrictions now are x cannot equal negative 6 and 3. Again, looking at the simplified form, we only see that x can't equal negative 6. However, we know that this is just the simplified form. In our actual expanded form, so to speak, or the unsimplified form, x can also not equal 3. If I look at C, right, x squared plus 10x plus 21 divided by x plus 3. So looking at my expression as is, I can look for restrictions. I can look at the denominator. So x cannot equal negative 3. So that's a straightforward one because x plus 3 can't equal 0. So x can't equal negative 3. There's nothing else that's going to be on the denominator. So that's going to be my only restriction, right? I'm not simplifying anything on the bottom or anything like that. However, to simplify the overall expression, I can factor the top. So I'm going to be looking for two numbers that multiply to 21, but add to 10. That would be 7 and 3. So I have x plus 7 times x plus 3, all divided by x plus 3. Oh, I have a similar, my value in the denominator is similar to a factor or a multiplication or a factor in the numerator. So that entire term and this entire term or binomial can cancel out. I'm left with then equal to x plus 7. And my only restriction in this case, right, the denominator hasn't changed. There's no denominator in this fraction, but my restriction is that x cannot equal negative 3. Because again, it goes back to the original expression. So the simplified expression is x plus 7, but the restriction is x cannot equal 3. Again, D, very similar. Right now, nothing with the trinomial that I can come up with any restrictions. I can do the product and the sum. So two numbers that multiply to 2 and add to 3. Well, that's 2 and 1. So I can rewrite this x plus 1 divided by x plus 3 times x plus 1. Now at this point, I can come up with my restrictions, or I can see that there are going to be some restrictions. The restrictions are that x cannot equal negative 3 or negative 1. Right? If you need to go through and set each factor equal to 0 or not equal to 0 and then solve for x, you're more than welcome to, but hopefully we are becoming a little bit more familiar with, okay, well, move the plus 3 over, becomes minus 3, and so on. I can now go through and simplify. I can cancel out this factor on the bottom with the x plus 1 on top. I'll be left with 1 as a placeholder and x plus 3 in the denominator. Oh, not 3. Sorry, my mistake. That should be a 2. Both parts. So x can't equal negative 2 and negative 1. My simplified form is 1 over x plus 2. And the restrictions are that x cannot equal negative 2 and negative 1. And that's my simplified form with restrictions. Looking at some other examples, again, going through, I have x plus 2, or sorry, x to the power of 2 divided, or sorry, let me start again. X to the power of 2 minus 9 divided by x squared plus 7x plus 12. Looking at the bottom, looking at the denominator, there is no kind of restrictions that I can see yet, right? But from what we've done before, I can factor it to figure out what my restrictions will be. I can also factor the top because the top is a difference of squares. So again, we might have to refer back to our previous lessons on factoring, just so we kind of have that kind of memory jog of things to look for, the patterns. Right, so x plus 2 minus 9 becomes x minus 3, x plus 3 on top divided by, and on the bottom I'm looking for a product and sum. Two numbers that multiply to 12 but add to 7. This would be 4 and 3. So on the bottom I'd have x plus 4 times x plus 3. Now looking at my expression, now I should be able to see, oh, I can see two factors in my denominator. It's going to be a lot easier to set it equal to 0. So my restrictions right now are going to be x cannot equal negative 4 and negative 3. So I have my restrictions right now. I'm going to continue through and start to simplify. Looking at it, I have a factor on the top and a factor on the bottom that I can cancel out. This would leave me with x minus 3 on top divided by x plus 4. So again, now I'm adding terms. I can't cancel out the x's, and I can't cancel out the numbers. because I'm adding and they're not identical. If they were identical, I'd cancel them out, make it just 1. But I can't in this case because I'm adding, so I can't cancel anything out. So I'm going to leave it as is. I'm just going to restate my restrictions because there's nothing else that can be added. And this, what I mean by nothing else can be added, will make more sense when we look at some other examples where there will be restrictions appearing as we go through the process. F. So again, F, a little bit more complicated because now we're dealing with complex trinomials. Right? So we have two numbers. I can't do anything in terms of restrictions. I want a factor. So I'm looking for two numbers, do one on the top, two numbers that multiply to negative 30, which is the 6 times negative 5. And two numbers, and the same two numbers have to add to negative 7. And then for the bottom, I'm looking for two numbers that add to negative 30, or sorry, multiply to negative 30, but add, from the 3 times negative 10, but they add to 1. So if I look at these two values, or I look at what they could possibly be, for the first one, so two numbers that multiply to negative 30, we have, but add to 7, we would have negative 10 and positive 3. For the next one, we would have positive 6 and negative 5. So factoring, we're going to factor the top by grouping. So 6x squared minus 10x plus 3x minus 5 divided by, on the bottom, 3x squared plus 6x minus 5x minus 10. There's still nothing I can do in terms of finding any restrictions, so I'm going to go through as normal. I'm going to factor, continue to factor. Factor by grouping the top, I can take out a 2x, and I'm left with 3x minus 5 plus 3x minus 5. I'm going to put that in brackets because that's a common factor that I'm going to take out later. In the denominator, common factor the first two terms, I can take out a 3x, get x plus 2. I can take out a negative 5 because my goal is to get the same bracket, x plus 2, which I do. Now, on the top factor, common factor, I can take out bracket 3x minus 5, and the remainder 2x plus 1. In the denominator, x plus 2. And 3x minus 5. All right, now I've factored everything. I've factored everything as much as possible. Looking at it now, okay, I see some restrictions that could come into play. I see factors on the bottom. It's a lot easier now. So I know that x cannot equal, well, x plus 2 said equal to 0. Okay, x can't equal negative 2. 3x minus 5. Okay, move the 5 over. That becomes 3x equals positive 5, divide, so I have 5 over 3. So those are my restrictions right now. So all I did was I set the denominator equal to 0. We're going to use a different color for that. So x is equal, or x plus 2 can't equal 0, and 3x minus 5 can't equal 0. And I went through and I solved both and got negative 2 and 5 over 3. Now that I have my restrictions at this stage, I can go through and start to simplify. I see a factor on the bottom and a factor on the top that are common. I can cancel them out. I'm left with 2x plus 1 divided by x plus 2. I'm adding now, so I can't cancel anything out. So that is my simplified form. I'm going to restate my restrictions. X cannot equal negative 2 and 5 over 3. So a lot of things going on in this one, right? We had to factor complex trinomials for both parts, and then we had to look for restrictions and then cancel things out to simplify our expression. So that's just looking at rational expressions. We haven't had to do any multiplying or dividing. That's going to be what we look at next. So multiplying rational expressions. So what we want to do, we want to factor where possible. So we want to factor anything that we can, right? Looking for trinomials, differences of squares, maybe common factoring if we have multiple terms. If we have one term, then we don't really have to worry about factoring. We want to cancel common factors, and then we want to multiply numerators and denominators. So we want to kind of cancel any common factors before we multiply, so canceling things out separately, and we want to state restrictions. However, we want to state restrictions throughout the process. This is something we want to do in an ongoing thing. So this is where it's going to get difficult, because we aren't just going to look at the very end and say, okay, what are my restrictions? We're going to be going through and doing it as we go. So this is where I had it in different colors, so it's going to be a little bit more useful now rather than the last one where it's like, okay, state my restrictions. Oh, I'm done. I've simplified it, right? This is going to be more of a process. So if I look at 4x squared divided by 3x times 12x cubed divided by 2x. So looking for any restrictions right now, I have x's in both. So again, I don't need to really state any more than one variable. I can just say, okay, x can't equal what? Well, looking at it, it's 2x can't equal 0, 3x can't equal 0, okay? So in both cases, x cannot equal 0. And again, where do we get that from? 3x can equal 0, move the 3 over, 0 divided by 3 is 0. Same with the 2x, same idea. So right now, x cannot equal 0. Now, let's go through and simplify. So I can cancel out, I can't really cancel out any numbers, right? But I can cancel out some variables in the first one. I can cancel out the x and an x on the top. I'll be left with 4 over 3x, and that's going to be multiplied. Okay, I can simplify the 2's, the 2 and the 12. 12 divided by 2 is 6. And the x cubed becomes x squared. So now I've simplified it to 4x, or 4x divided by 3 times 6x squared. Go through, see if there's anything else that I can cancel out. In this case, no, not really. So I'm going to go through and multiply. There are no restrictions at this point because I have 3 at the bottom. 3 can't equal 0. Well, yeah, of course, 3 can't equal 0. It's just a number. There's no variables in any of my denominators, so I don't have to worry about any restrictions right now. Go through. 6 or 4x times 6x squared gives me 24x cubed divided by 3. Dividing by fractions, multiply numerators, multiply denominators. I can now cancel out 24 divided by 3 gives me 8x cubed. There are no more denominators. There's no variables in my denominator, so my restriction is going to be x cannot equal 0. So my simplified expression is 8x cubed, and the restrictions are x cannot equal 0. Again, this one's a little bit straightforward in terms of the restrictions. Multiplying and canceling out is, again, also fairly straightforward. Now let's look at b. So this is where it gets a little bit more complicated. 4x plus 24 divided by x squared plus 8x times 12x squared minus 3x plus 18. All right. This is now where it gets a little bit tricky. Right? If I look at this, I want to factor where possible. So for my numerator, the first one, I can factor out a common factor of 4. I get x plus 6 times 12x squared stays the same. Denominators, x squared plus 8x, I can factor out an x. I get x plus 8. And on the other side, I can factor out a 3, x plus 6. Now that I've factored it, I should recognize, okay, I do have some variables in my denominator. I can go through and take a look at some restrictions. Well, for the first one, We'll go through and we'll highlight it. So x. Okay, well, x is on its own. X can't equal 0. Good, that's my first restriction. The next one, x plus 8. All right, x plus 8 can't equal 0, so that means x cannot equal negative 8. Good, that's another restriction. And on the other fraction, x plus 6. Okay, x plus 6 can't equal 0, so x can't equal negative 6. So those are my 3 restrictions right now. Now I'm going to look and see, is there anything I can cancel out? Right? And now the nice thing about multiplying, because we multiply straight across, essentially we might just say, well, I'm just going to bridge this bracket, right? And I have 4 times x plus 6 times 12x squared divided by x times x plus 8 times 3 times x plus 6. Because everything is being multiplied, I can cancel things out, whether it's on the one fraction or the other. So for example, I can cancel out the x plus 6 and the x plus 4. I can cancel out the 3 with the 12, so I'm left with a 4. I can cancel out the x with the x squared to make it just x to the power of 1. So going through, I would be left with 4 times 4x divided by x plus 8. I can simplify the top. This would become 16x over x plus 8. I can't simplify anything further because on the bottom I'm adding, so I can't cancel anything out. I can now also state my restrictions finally. X cannot equal 0, negative 8, negative 6. I should have mentioned, technically we could look at this x, this next step in the process. While looking at it, x can't equal negative 8. Oh, we already had that restriction. I don't need to restate it. Same thing with in the end here. I could look at that and say, oh, I have a kind of a different denominator, but still the restriction would be x can't equal negative 8, which I already have, so I don't need to go through and restate it. The next one, x plus 1 divided by 2x times 3x divided by x squared plus 4x plus 3. So looking at it, there's nothing I can really common factor in the first one. I can factor the denominator of the second one because it is a trinomial. But before I even do that, I should see, oh, I have an x. I can state a restriction. X cannot equal 0, right? If I set 2x equal to 0, get x by itself, I get that x cannot equal 0. So at least I have one restriction right now of what x cannot equal. Next, I'm going to go through and factor. So x plus 1 is going to stay the same, divided by 2x times 3x divided by, I have a product and sum, two numbers that multiply to 3 and they add to 4. So that is going to be 3 and 1. So my denominator is x plus 3 times x plus 1. All right. I can state new restrictions now. So x already couldn't equal 0, but now when I look at these second factors over here, x also can equal negative 3 or negative 1. I can go through and simplify. So I stated my restrictions, now I can start canceling out. You don't want to cancel out until you've checked for restrictions. I don't want to do anything yet or until I figure out my restrictions, which I did. Now I can start canceling out. I have an x plus 1 on the bottom and x plus 1 on the top. I have a 2x and on the bottom and a 3x on the top. I can cancel out the x's. So that would leave, and I can't really cancel anything out. I can't cancel out the x plus 3. There isn't an x plus 3 on the top, and it's adding in between, so I can't do anything separately. So that means on the top, I'm left with 3 divided by 2 times x plus 3 I can go through and simplify this a little bit more. On the top, it's going to stay the same 3, and on the bottom, 2 times x plus 3 becomes 2x plus 6. So that is going to be my simplified form. I could have checked again, oh, there's a variable there, but it's the same one we've had before, or the same factor, so I don't really need to go through and restate, oh, x can't equal -3, I already have that. So I have my simplified expression. I can restate now all of the restrictions. So my simplified expression is 3 divided by 2x plus 6, and x cannot equal 0, -3, or -1. E, again, just a more complex example. We have a complex trinomial on top. I have 2 denominators. They can't be factored any further. So that is nice to know, because that is probably going to help when I go through and state my restrictions. There's nothing I have to factor or change on the bottom. But so let's state my restrictions right now. X cannot equal, in the first one, x cannot equal +7. And in the second one, move the 8 over, it becomes +8, divide by 5, so x can also cannot equal 8/5. I can't factor anything in the bottom, but I can factor the top. So I can factor this 5x squared minus 13x plus 8. So I'm looking for 2 numbers, product and sum, 2 numbers that multiply to 40, but they add to -13. So I would have -5 and -8. So 5x squared, -5 and -8. 5x squared minus 5x minus 8x plus 8 divided by x minus 7. That's multiplied by, on the other side, 5x minus 8, or 1 over 5x minus 8. Nothing I can factor there. I'm going to still continue to simplify the top, so I have 5x. Actually, let me do this. I'm going to do this off to the side, and this might be something that you choose to do as well, just to kind of avoid having this long string where it's just the one thing changing. I'm going to factor this off to the side. So then I can take out a 5x. 5x, I'm left with x minus 1. And then I can take out a -8. So I have -8 and then x minus 1. So my factored form becomes 5x minus 8 times x minus 1. I'm going to take that and put it back in. So 5x minus 8 times x minus 1. Again, the nice thing is I don't have to restate any restrictions because I don't have any new factors in the bottom. I haven't factored anything, it's staying the same. So I can go into canceling things out. I can cancel out this 5x minus 8 on the bottom and on the top. So I'm left with x minus 1 times 1 divided by just x minus 7. Or just x minus 1 divided by x minus 7. Again, I don't need to go through and restate any restrictions or look for any new restrictions because I haven't changed anything to the bottom. I've simplified it now, and I can now state my restrictions, which is 7 and 8/5. My simplified form is x minus 1 divided by x minus 7. The last types we're going to look at are dividing rational expressions. So dividing rational expressions, we're dividing the same way that we deal with fractions in general. We have to flip the second fraction and change the operation to multiplication. We want to factor where possible. We want to look to cancel out common factors. We want to multiply then our numerators and denominators. And again, similar to before, we want to state the restrictions throughout the process. So let's take a look at the first one. 10ab squared divided by 4a, and then that is all divided by 15a squared divided by 12b squared. So One thing to note when we're dividing fractions, yes, the first step is to flip the second fraction and then multiply. However, step 5 says we have to state the restrictions. So one thing to note, well, one, we don't want to cancel out. So do not cancel out until you flip. Do not cancel out until you flip. And check restrictions first. So we want to check for restrictions first before we flip it, because we always have to go back to the original expression when we're looking for restrictions. And we don't want to cancel anything out because we only cancel it when we multiply, and we're not multiplying yet. So we're going to look for restrictions. Let me just kind of move this up and off to the side. I'm going to check for restrictions. So I have nothing I can really simplify in the denominator. So I have a cannot equal 0. And I have b cannot equal 0 because those are my two variables. I can't really factor anything, so I don't have to worry about that. Now I can flip. So now I can flip the second fraction. So ab squared divided by 4a times, I'll put a dot so we don't get confused with x's, so times 12b squared divided by 15a squared. Now I can go through and look to cancel things out, or I can just multiply through and cancel it out because there's no real factors right now. So I have 120 ab to the power of 4, because again, adding exponents when we multiply, divided by 60a cubed. Again, no new restrictions have come into place because looking at the bottom is just a. There's no factors, so a just can't equal 0. I can cancel out my values and be left with 2 and 1. Cancel out the 3 and be left with -2. Or you could think of it as, well, I have 1a on the top, canceling out 3 on the bottom. I'm left with 2 on the bottom. So that way you don't even have to worry about getting a negative fraction and then flipping it. So I'm left with 2b to the power of 4 divided by a squared. That's my simplified expression. And my restrictions are a cannot equal 0 and b cannot equal 0. For b, a little bit more complex because now we have components that we can factor. But before we do that, again, check your denominators. Okay, I do have two values, or I do have two variables. So right now my restrictions are that a cannot equal 0. Good, done. I'm going to flip. So I have a squared plus 2a divided by 3a, now multiplied by 20a squared divided by 5a squared plus 10a. I can factor the bottom of this one fraction. A squared plus 2a divided by 3a, now multiplied, I forgot, I'm going to keep it as a dot, 20a squared, divided by, and I can common factor out a 5a, then I'm left with a plus 2. Did miss something, so thinking about that, right? I could also common factor the top and get a, factor an a and a plus 2. So I could have done that as well. It doesn't really change anything with restrictions because it is in the numerator. However, these two variables on the bottom, I do have to check for restrictions. The 3a I've already done at the beginning. That hasn't changed. The 5a also doesn't change. It still makes it 0. However, the a plus 2, that adds in a restriction. a cannot now also not equal -2. Okay, I've checked for restrictions. I've already flipped it. I've factored it. Now that I flipped it in its multiplication, now I can look to cancel out. I do have an a plus 2 on the bottom and an a plus 2 on the top. I can cancel that out. I do have an a and an a that's being multiplied. I can cancel that out. I have a 5 and a 20. I can cancel those out. I'll be left with 1 as a placeholder. And I have a, instead of 20, it becomes 4. And this a would cancel out the a squared to make it a1. I guess I'll just cancel out the exponent to make it 1. So shifting through all of this, all that is left is 4a over 3. I can't simplify anything further. I can't cancel anything out. So I'm just going to restate all my restrictions now. A cannot equal 0 or -2. Now, if you don't like this method of canceling things out, similar to what we've just done here, right? There are some things that you would want to, right? The factors, right? A plus 2, that's an easy one to see. Other ones, so let's say, for example, let's just kind of do this separately. If I had a, the a plus 2 is gone. I know it's divided by 3a times 20a squared divided by 5a. If you don't want to cancel anything out with this, or you're a little bit unsure, go through and multiply. So you have 20a cubed over 15a squared. Your power laws state then that this has to simplify to 4 over 3a. So if you don't like canceling out the individual factors other than obviously the big ones, feel free to multiply, right? If there's nothing else you can factor, multiply, right? And then use your power laws to simplify. But again, that's just kind of like a quick in between. If you don't like canceling out the factors that similar to what we've been doing. C is our next one, and again, this is just more complex rationals. So again, let's go through and take a look. Looking at my denominators, there's nothing in the denominators that I can do, right? I can't factor anything, I can factor, but there's no restrictions that I can state. So before I flip it, I want to factor, right? So 2x squared minus 8x, I can factor that as well. I can take out a 2x, or a common factor out of 2x. I'm left with x minus 4. On the bottom, again, I'm going to do these off to the side to save me some space. So x squared minus 3x minus 10. Product and sum, so -10, sum of -3. That would give me -5 and +2. So I'll have x minus 5 and x plus 2. And in the second one, the 4x squared I can't factor out. I'm going to leave it as 4x squared. The x squared minus 9x plus 20, that is a simple trinomial. So x, let me move this up a little bit. So I have x, I'll do it underneath, x squared minus 9x plus 20, product of 20, sum of -9. So in this case, my two values would be -5 and -4. So that means I have x minus 5, x minus 4. Now that I factored it, I should see that I have restrictions. So x cannot equal, if I look at the first factor, x minus 5. So that means the restriction is x can't equal 5. X plus 2, so a restriction of -2. X minus 5, we've already got that taken care of. X can't equal 5. X minus 4, the next one, let me highlight it. X can equal +4. So I have 3 restrictions right now. Now I can flip. So 2x times x minus 4 divided by x minus 5 times x plus 2 times x minus 5 x minus 4 divided by 4x squared. So again, before we cancel out, let's check for restrictions. Oh, we do have a new one looking at this 4x squared. So in this one, x cannot equal 0. So now I have a new restriction in this portion. Nothing else has changed in the other fraction. I'm going to go through now and cancel things out. I have the x minus 5 and the x minus 5. Those can cancel out. I have the 4x squared and the 2x. So the 4 and the 2 could cancel out. And the x squared and the x would cancel out. So I'd be left with x minus 4 times x minus 4 divided by x plus 2 times 2x. No new restrictions, right? No new factors in the bottom, so nothing new there. In terms of canceling things out, there's nothing else I can really cancel out. I have a perfect square. I don't think there's anything perfect square. So now I can just simplify this a bit. So I have x squared plus, what is it? 8x minus 8x plus 16 divided by 2x squared plus 4x. So all I did was just expand both, just to simplify, and my restrictions are x cannot equal 0, 5, or it doesn't really matter what order they go in, 0, 5, -2, and 4. So those are the values that x cannot equal. Those are my restrictions. And again, depending on how you want it or how you consider it simplified, if we want to keep it in factored form, right, it could also be just x minus 4 squared divided by 2x times x plus 2. So I guess technically that would be the more simplified form. We've been always just kind of expanding in some cases and going backwards. But you could argue that this is the most simplified form. So actually, let's just put that below. So even though we kind of expanded it, I would say this is the more simplified form. And if you want to get technical, you could state that the restrictions should go in kind of lowest to highest. So for sake of argument, why not keep it consistent? So we have -2, 0, 4, and 5. So this is tricky in the sense that you have to kind of really follow the steps and really kind of be neat with your lessons, or not your lessons, with your notes, because of how much is going on in each step. So again, just take your time. This is where the practice really comes into play. 1, to help with the factoring, because you do have to recognize that. And 2, just knowing when to look for restrictions, making sure we don't kind of jump the gun and cancel things out, or get rid of things before we actually look for restrictions. So again, new concept, taking old concepts that we've looked at before and kind of combining them. So again, practice is really going to help. Making sure that you are feeling comfortable with this. Right? These aren't things that you can just look at and then like, you know what, I got this. Right? Probably new concept will require some practice. So make sure you are practicing and asking for help if you need it.